All right, lesson 2.6. I'm going to get started, and this lesson has 4 review problems, 2 on the bell ringer, and then 2 after bonus for us. I'm going to start with number 1. And before I actually read this long problem, I gave you a technique a few classes ago, whether it was last class or the class before. Can't remember off the top of my head, but I told you when you are doing word problems and you have an equation, there's something very important that I would suggest you do to help your success in solving this word problem. What was the key I told you? A way of helping you solve a real world problem. We will graph it. We are not going to consider the negatives answers. That's all part of it. There was something at the start about when you read it as well. Circle the variables, because you can change your real world to become a mathematical problem once you fill in all that information. So I want to keep that in your mind as we start this. Number 1, Brent, that's my first name if you didn't know, dealing with blood disorder, diabetes. Before you panic, because other students have. I actually don't have diabetes, but a lot of people on my mom's side of the family do. And so I did a lot of research, came up with what is a normal function for people with with diabetes. So it says here, me dealing with blood disorder diabetes must closely monitor my blood sugar S of T. I'm going to stop. It said S of T. What is S of T? Blood sugar. I'm going to mark that. Blood sugar is S of T. After eating a meal, the rise in my blood sugar can be modeled by this equation. There it is. Where T is time and hours. Okay, I'm going to stop. What is T? T is time, specifically in the unit of hours. If my blood sugar needs to remain at a level of 80 or greater. Okay, so here we go. 80 milligrams per deciliter or greater. What is that referring to? Is that a time or a blood sugar variable? And you can look at the unit. Is the unit a measurement of time, or would that be a measurement of blood sugar, you think? Milligrams per deciliter. That would be blood sugar. So what we can do is substitute this in for S of T. And now we can say all this real world problem, all I need to pay attention to is the math side of it. So the question though is, how much time can I wait to eat another meal? I'm going to open up Power School Learning. I'm going to chapter 2. This is lesson 2.6. So I scrolled all the way down to the bottom to 2.6. We've shown up, we've signed in. I'm opening up in class work packet. And I'm going to resume this. And on your Chromebook, you just use 2 fingers to double tap the Desmos, open a new tab. Since I have an equation I'm solving for, what type of graph would that be? If you have an equation, you're just going to solve for the equation. Which am I pre-programmed? InSolve. I'm going to open up InSolve. And so first, the one adjustment you need to make is when you type these in, use the letter X for the InSolve. You can use T and it'll work, but it doesn't show all 3 graphs. So I'm going to, instead of using a T, I'm just going to use X. So please be following along here on your own if you could. Or at least get open a graph yourself. So when I give you one, whoops. Let's see here, minus 1600 T, minus 1600. Oh wait, I need to be X there. That needs to be X over X squared minus 8X minus 20. All right, so first I typed in the equation. I know it's a long equation, but there I typed it in. Secondly, what you need to do is y equals the left side, which means y equals 80. And thirdly, you graph y equals the right side of the equation. So I highlighted everything. I held down Control and I pressed C to copy it. So now I'm going to come over here and I'm going to hold down Control and press V to paste it. The solution is where the graphs intersect. And I need to zoom out so you can see the intersections well. They're going to be up at 80. Here's the intersections. How many solutions do you see in the 3 graphs? The green, the red, the purple. How many do you actually see? 4. Not all of them are going to be real world. I'm going to edit this. The X's, they're all real tight. So I'm gonna just go from like negative 10 here, negative 10 to positive, I don't know, 20. And I'll get all my x values. The y's, I'm still not seeing the type. I'm gonna change the y's to go a little higher. Oh, I need to go higher than that. There we go, to explain this problem. So it looks like there's 4 answers, but this is a real world problem. So we've already discussed this. In real world, where must my answers be located?
On the right side.
They have to be in the first quadrant. So is this first answer possible? Can I wait a negative amount of time to eat food? That's what the problem asks. How much time can I wait to eat another meal? Okay, so that one's out. That's not real. Can I wait 0 hours before eating a meal? No, that's where the problem starts. So that one's out. So now we've eliminated, and we're down to 2 answers. Let me interpret this for you. The green represents my blood sugar. That the green is this equation. That's representing my blood sugar. So I eat food, and as my body digests it, what happens to the blood sugar? It rises. And so this point right here would represent when the food is totally digested. When I just finished digesting it, my blood sugar is as high as it's going to be. And then my body starts working out the blood sugar. However, you got to go to your science classes to learn how that happens, but your body starts breaking it down. And now your blood sugar starts tanking. What happens if it gets below this 80? I might not die right away, but my body would start going into having some issues, right? Okay, what happens? I'm going right back to you, Peyton. What happens if my blood sugar gets all the way to 0? Now I'm dead. At this point, I'd be dead. So here's a question. This says it happened, I'm dead at 8 hours later. Now at 12 hours, so 4 hours after I'm dead, someone comes and shoots me up with some blood sugar or some sugar. Do you think that's going to save me? No. Is this part of the problem real? It's no longer relevant is the word. It's no longer relevant because I've already died. So this part's not, it doesn't even matter. I went outside. Another way of saying this is my graph went outside the first quadrant. So the problem stops right there. That's where the problem starts. It did not start till 0. So all this is gone. We were only looking in this region. And so this is the time I'm healthy. So I can wait up to 7.283 hours. If we look at our, oops, need to clear that now. If I look at my question 1, it says round your answer to the nearest 1/10 of an hour. 1/10 has 1 0, a 10 has 1 0, so that means 1 decimal. So if you're gonna round that to 1 decimal, would be 7.2 or 7.3? 7.3 would be the answer. I can wait up to 7.3 hours. How much time can Brent wait? Brent can wait. I can wait up to 7.3 hours. Any questions over that first one? So one more time, what was wrong with this answer? Can you wait a negative amount of time? No. And this one was that I was already dead. And what's wrong with 0? That's when the problem started. I haven't waited any time, so I have to go after that. So that was there, number 1. Okay, what about number 2? It says write an equation that represents a slant asymptote. So if you remember, the asymptotes, as he talks about horizontal and slanted, follow those 3 rules, whether the exponents were bigger on bottom, bigger on top, or if the exponents were the same. Which case is true here? Is my exponents bigger on top, bigger on bottom, or are they the same? Bigger on top. So by rule, last class, we learned that if the exponents were bigger on top, there was no horizontal asymptote. Instead, it was going to be slanted or oblique, depending on the equation. And what I told you next is slanted or oblique asymptote. What I told you is you actually just divide the equation. So I'm going to do this by hand. Can we use the simpler synthetic division, or do I have to use long division on this one? So the question you need to ask yourself is, could I solve for what x equals in the denominator? What does x equal? Do we know what x equals? No. So if you don't know what x equals, you need to use long division. So long division, the way it works is the divisor goes outside the house. Inside the house is the dividend 2x. Oops, that should be a cube. 2x cubed minus 5x squared minus 8x plus 1. The slanted asymptote will be the quotient, by the way. So to start this off, what you need to ask yourself is, what is my leading term dividing by my leading term here? My leading term inside the house divided by the leading term outside the house. What is 2x cubed? That's like 3x's divided by x squared. What's the answer there? Those go away. We left with 2x. Okay, so I know my equation is going to be y equals 2x. We'll discover the rest as we go on. So I'm going to distribute the 2x. 2x times x squared is that 2x cubed. 2x times a negative x. Ooh, what is that? Negative x times 2x would be negative 2x squared. Great. And then finally, 2x times a positive 5 is positive 10x. So I go to simplify, and you need to remember what I call the fundamental rule of division. What was the fundamental rule of division? We switch the signs. That becomes a negative. This becomes a positive, and this becomes a negative. Negative 5x squared plus 2x squared equals negative 3x squared. This would be a minus 18x plus 1. And on this step, we'll get our answer. I again do, what's this leading term? Divided by this leading term. Leading term inside the house divided by leading term outside the house. What is negative 3x squared divided by x squared? That would just be negative 3. This is going to be my solution. The quotient is y equals 2x minus 3. That's going to be my solution. You don't have to finish this problem off. That right there is it. Y equals 2x minus 3. That's my equation. You don't have to worry about the remainder. When I graph this, I'm just going to close everything off so I have a blank graph. I'll show you this equation, what the slanted asymptote will resemble. 2x cubed minus 5x squared minus 8x plus 1 over x squared minus x plus 5. Okay, by the way, as I graph this, when we look at the answer, I want you to know that you don't have to do all that algebra I just did. If you want to try to use your calculator, I'll show you a great way of using calculator as a cheat. Let me first show you the answer though. Does this look like, when I zoom out, what can you tell me about those two graphs? There's a red graph in there and a blue graph. What can you tell me about those two graphs? They look exactly the same, don't they? That's because it's asymptote. Wow, that was a lot of it's in there. It's asymptote. Now, zooming in, you can see these aren't exactly the same, but when you zoom out, you can quickly say that's its asymptote. So that is the correct answer. Now, let me show you a way you could have done this if you wanted to use just calculator. So you ready to reload? We're starting this problem all over again. You're supposed to find a slant asymptote. You first graph this equation and you see this graph. Does it diagonally have a slanted asymptote? Like, can you tell that it's going off slanted, like a slanted line? Can you make that observation? Okay, so here's how you can do this without using a calculator, by what I call guess and check technique. Leading term divided by leading term. What is 2x cubed divided by x squared? 2x cubed divided by x squared. Okay, so you could, with that, say, okay, y equals 2x. What happens is you can tell the slope is right, but as I zoom in here, you can tell that this green line is not in the middle of the red, meaning it's these lines cross down here on this lower side. On the top side, there's more space. So do I need to shift this green line upward or downward to make it more in the middle of the red graph? Up or down? Down. And so I would just try subtracting one at a time. Did that balance the space equally? I can see it's better, but is it balanced? No, so I subtract again. This is again better. Is it balanced? No, we would need to do it one more time. Is this balanced? Yeah, that's it. And if you wanted to keep trying, you could, but now at 4, you can see now we're going the wrong way. Now it's getting too small up there as it's getting too large down there. So the correct answer was y equals 2x minus 3. That's a way of using technology to solve the same thing. Did that make sense what I just walked you through there? The only math I did was ask you what's the leading term divided by the leading term, and then we did guess and check from there. So with that, I've got 2 review problems. Do you want me to use calculator technique or algebra to do these next 2? Algebra, great. Remind me. So this is a review test. Next class, I want to review some of the key concepts here. The first one is domain. Domain, I've told you to assume is all reals. You assume it's all reals unless you see one of 2 symbols. David, do you mind putting that away? Assume the domain is all real and all reals unless you see one of 2 symbols. What 2 symbols do you look for? Division and square root. Okay, on this problem, what do we see? Division. What are you not allowed to divide by? 0. So the domain, using a number line, this is the way I first taught you, using the number line, the domain would be all reals except for 0. Only at 0 would the graph not exist. So a domain will have one break somewhere. I'll do an open circle, but the rest it'll be exist both going left and to the right. Now what you would do is you're not allowed to divide by 0. So this 0 value might actually change it just slightly. So you'd say, okay, x plus 2 cannot equal 0. And you would just solve that using algebra. I have an x being added by 2 to isolate this x. What do I need to do to the plus 2 to get rid of it? We'd subtract 2. And now we get our new value that x cannot equal -2. This graph will have one break and it'll be located at -2. It'll exist forever to the left. It'll exist forever to the right. It'll just be broken at -2. That's our domain. Another way of saying this is all reals except -2. Or you could write it this way, from -infinity, from left forever all the way to -2. Open circle means a parenthesis break. And then we have a second interval that also starts at -2. And it goes to positive infinity. You could also write it this way. So there's 3 different ways I just showed you. You can, there it is in English. Here it is in interval notation. And here it is using inequalities. All 3 mean the same thing. That's domain. A vertical asymptote is a break in the domain if the value the factor does not actually cancel out. Does this x plus 2 cancel with x minus 2? Are they the same or different? Different. Since it does not cancel, it's a vertical asymptote. So we have a vertical asymptote at the break. So the graph itself, the graph of f will be broken at -2. What fills the break is what we call a vertical asymptote, a straight vertical line at -2. Finally, horizontal asymptotes. If you were doing this, you would need to use, you need to have standard form. So I would need to distribute this out, and I will just stop here. I'll just do x squared ... And on the bottom, it's x plus 2. Is my exponents bigger on the top, bigger on the bottom, or are the exponents the same? Bigger on top. So bigger on top had an n, which means no horizontal asymptote. This would also be slanted or oblique. Both names would work. It's either a slanted or oblique asymptote. And so again, you would use division. This time you could use synthetic or whatever. I'll just use calculator technique. I know y'all said algebra. I'm going to use his calculator. I do know what is x squared divided by x going to equal? X squared divided by x. Y equals x. So I know it's going to start y equals x. I'm going to graph it and find the rest of the problem here. So this time I've got x minus 2 times x plus 3, all divided by x plus 2. There's my equation. If I zoomed out, you can see that this is all reals except for -2. That's my one break. It is a vertical asymptote, also known as the infinite discontinuity. At x equals 2, that would fill that spot. Not positive 2, I'm sorry, -2. At x equals -2, that would fill that spot. I'll do it as a dotted line for a vertical asymptote. There it is, dashed line. And now our slanted asymptote, I know it's going to be y equals x. When you look at y equals x, that's the right slope. Is it placed in the middle of the 2 pieces though? Too high, too low? You look at this piece and this piece. Does this green look too high or too low? It's too high, so I'll lower it. What about now? Looks pretty good, doesn't it? Let me try one more time just to make sure. Go back. It's going to be y equals x minus 1. That would be my answer there. Y equals x minus 1. That's the slanted asymptote. And I have one more here. It says determine any asymptote holes or intercepts of this equation, then state the domain of G. This time I've given you the problem in standard form. And so if you're going to use algebra, you would need to find all these values in factored form. So first for domain, what are you not allowed to divide by? 0. So for my domain, because that's what it does ask for domain, you would need to factor this. So let's do an X method up here. X method, and we're going to use, this is my A, B, and C. So factors of A times C that add up to B. So factors of 1 times 18 that add up to be -9. Now you might already know what they are, but I'm going to go ahead and put up my T-chart. So I'm looking for factors of 18 that add up to -9. There's 1 in 18 as a possibility. 2 times 9, 3 times 6. I think that's it. 4 doesn't go in 18, 5 doesn't go in 18. That's it. Which one of those can add up to be -9? How do I make that add up to -9? Both negatives. Whoops, that was a mistake. -3 and -6. So here's what that means. You would split your A terms power, and we'd find out we could rewrite G of X as X minus 3 in the denominator times X minus 6. The numerator, this one's a little bit easier. You have a GCF. What's common between both of these? So if I divide out an X, I have X squared minus 9. I GCF'd out an X. That was GCF there. But I can actually simplify this. This is a difference of squares. Which term am I missing? The A, the B, or the C? You're dealing with quadratics. Am I missing my A, my B, or my C term? My B. Hey, Jaden. Jaden. Or is that Jordan? Sorry, Jordan. There you go. So I'm missing my B term. You can do square root technique, which means difference of squares. You take the square root. What's the square root of X squared? X. That goes in the front of both parentheses. And then what's the square root of 9? 3. And you make 1 positive, 1 negative. That's difference of squares. And so this is my equation in factored form. And so first off, for domain, we're not allowed to divide by what number? 0. So just to make this quicker, what can X not equal here? Sorry, if it cannot equal 0, what is it when I add the 3 over? X cannot equal positive 3. What can X not equal here? X not equal positive 6. So your domain, you could write it in this form, or you could say from -infinity all the way up to, let's see, 3 would come first. Union 3 to 6 and union 6 to infinity. I'm about to show you this in the graph. That would be the domain. So you have those 2 breaks. A vertical asymptote would occur where the factor does not cancel out. So let's look at these. Do either factors cancel out? Which one? Those cancel out. That's going to be the removable discontinuity or the hole. That means this one's the vertical asymptote. So we have a vertical asymptote at X equals 6. You have a hole at the X equals 3 value. Now a hole oftentimes will actually find the exact location, and you would put in 3 into the simplified equation. So if I plugged in 3 for X, it would be 3 times 3 plus 3 divided by 3 minus 6. That'll be the point. Let's simplify that. 3 plus 3 is 6. So what is, I'll just write it out step by step. 3 minus 3, 6 is -3. And one more time here. What is 3 times 6? 18. Divide that by -3. I lied. I said one more time, but now we have to do one more time. So the whole would be located at an x value of 3. What's 18 divided by -3? -6. That's where that white circle will appear on our graph. And I'm going to stop there. We could do the intercepts, but I'll just get it off the graph anyways. I'm going to go graph this and prove everything we just found is accurate. So I'm looking at x cubed minus 9x over x squared minus 9x plus 18. I'm going to delete these two things. Go home. Okay, so here's my graph. We said that there should be a vertical asymptote at x equals +6. So I'm going to type that in, x equals 6. Does that appear to be a vertical asymptote of the graph? Does that appear right? All right, we said there's going to be a hole in -3 or +3 comma -6. So if I click on this red graph and I go to 3, do I have a little white circle at 3, or it would be 3 -6? Look on the y value. Where's the y value of that white circle occurring? The x value at 3, but what's the y value? At -6. You see how that occurs at -6? We did that right. So when I plugged in that 3, that's what that did, is it showed me where that white circle would be. It would be at -6. So we do have those two discontinuities. This would be all reals, the domain, except for those 2 points. We have an open circle at 3. Let me find it. There it is. Open circle at 3 and a break at 6. Oh, I could have also shown you from the table. I could have shown you from here. We would have one at 3 and 6. So you can see we have 2 breaks at 3 and 6, 2 breaks. So anyways, that's your review. Let's take a look at new stuff. Today, we're going to deal with inequalities. So specifically, we're going to hone in on inequalities, which just means that the equation is not directly equal to. So the math today is nothing different. No new things that you don't know about, other than we're dealing with inequalities. And so I want you to know, first and foremost, Desmos solves this for yourself. Like, you can honestly go through these and graph all these and solve them real quickly. But I want to let you know what's happening algebraically. If we were to solve this, the way we would do this mathematically is you would set things equal to 0. And don't worry, I will show you graphing technique. I'm not just going to leave you on that. You would solve, but you would first set things equal to 0. Whenever you're solving with a power greater than 1, we set things equal to 0. So how would I set this equal to 0? How would I get rid of a +1 on the right side of the equation? You would subtract 1. And so the reality of what you're trying to solve is that x squared minus 8x plus 15 is less than or equal to 0. Now that's a trinomial. So we could do X method. You could also use that calculator I created. And you could say, all right, I'm going to take my factors of a times c over b here. What is 1 times 15? 15. And I want to find factors of 15 that add up to be -8. Now, 15 is easier. I'm not going to actually make the whole chart this time. I will. Sorry, I lied. There's 1 and 15, and there's 3 and 5. That's it. Which one of those add up to 8 somehow? -8 somehow. -5 and 3. We have a -3 and a -5. So now I would split my a terms power. And so it'd just become a 1x minus 3 and a 1x minus 5 is less than or equal to 0. So the values that would be the critical values, if you will, I'm going to use critical to say the critical values of x would not be -3. What's the critical value here? It'll be 3. So for a second, I'm just going to do like a squiggly +3, like with a squiggly, because I'm about to say I don't know what I should do with that, because I have 2 factors supposed to be less than or equal 0. That does not mean each one individually, because if you just think about this, that is saying the number can be negative, and that does, for a negative, and you have multiplication going, one term could be negative and the other could be positive, and you could be fine. So it could be either one. For that reason, I'm not going to do an equal sign. I'm just going to do a squiggly for a moment. The values are going to be x 3, and the other squiggly will be at 5. And so without using a calculator, what you would do is you would create a number line, and you would place the x values, -3 and -5, on my number line. Not -3, I'm sorry, +3, +5. That's on my number line. And what we would need to do is check within each interval. So the left of 3, between 3 and 5, and to the right of 5, to see if the values are greater than or equal to 0. The one solution I know that will be true, the two solutions I should say, to be equal to 0, they would have to be the numbers 3 or 5. So I want to do a closed dot there just because I do have the equal to line. If it was just a less than, it would be an open circle, but this will be closed. Now I want someone to pick a number less than 3. 2 is a good number. Let's plug in 2. If you plugged in a 2 here, what you would have is 2 minus 3 times 2 minus 5. Now quickly, is this just tell me, is this a negative number or a positive number on the left factor? That's a negative. Is this a negative or a positive? Negative. What happens when you have a negative times a negative? This is a positive interval. Is that what we want to have here? A positive interval or a negative interval? We want this to be less than or equal to 0. We want it to be negative. Will that be part of our answer? No. Okay, now someone pick a number between 3 and 5. 4. How about 4? So we have 4 minus 3, and we would have 4 minus 5. What is 4 minus 3? A positive or a negative? It's a positive. What about 4 minus 5? So a positive times a negative is going to be negative. That's going to be part of the solution in here. And let's test the last one. What's a number bigger than 5? I hear 7. 7's fine. What about 7 minus 3 and 7 minus 5? What can you tell me about those? Positive and positive. What's this going to be? Positive. That's not a part of our solution. The solution will be, the solution set, I should say, are all values between 3 and 5, and I will use brackets. Now, we did all this work. Check out what Desmos says. I'm going to go, I'm just going to type in this equation as the original problem. You're about to see something pretty sweet. The less than or equal to button, you can hit shift less than, which is the comma, and then do the equal button, and that can work, or you can open up the Desmos keyboard and press that right there. So what you can do is you can just do this symbol followed by the equal sign, and Desmos will automatically convert that. I type this in, and look what Desmos does for me. This is so sweet. It shows me an answer set as shaded, and between what two numbers is it shaded? 3 and 5. You see this dark solid line on the outside? That means it can be equal to it, so you'd use a bracket. It's between 3 and 5. How about that? Was that pretty neat? So did we need to do all this algebra? No, but don't you feel smarter? No, some of y'all are like, no, I feel duped. Like I did a whole bunch of work I didn't have to do. That's the case. Graphically, why is that the answer graphically? If I graph just the left side of the equation, y equals the left, and then I graph just the right side, y equals 1. What you're saying is, where is it that this parabola portion is below 1? And I want you to see, here's the parabola. Where is the parabola, this black parabola, below the red line? Between 3 and 5. Would y'all agree with that? This parabola is below the red line between the x values of 3 and 5. So that's why it's the solution set graphically. Okay, so next one. Do y'all want me to do algebra?
No.
All right, to do the algebra, what I'm going to do is I'm just going to copy and paste what we already did, because we already did all the work for part B. So I'm going to copy this. And the only thing I'm going to erase this time is my number line. Okay, so I'm erasing my number line on part B. First question I have for you. Can I be equal to 0, equal to 1 this time? No. So open circle or closed circle? Open. And so I can't be equal to it. It's going to be an open circle. This symbol has less ink. I'm going to have less ink this time here. So open circles. Do I want this shaded? Do I want to be positive or greater than 1 or less than 1 this time? Greater. And you could, if you subtract the 5 over, you could say, I want this to be greater. I do need it for the sake of this example here, set this equal to 0. So I want the parabola portion to be greater than 0. So now when I look at my number line, where's my answer? Is it the negative or the positive intervals? Positive. So this time my answer algebraically would be these two intervals, which would be from negative infinity to 3. It'll be a parenthesis because it's open. There's a break, so you symbolize that with a union. That means there's a break in a second answer set starting at 5, going right to infinity. That's my answer this time around. So this is copied from part A. So all that was copied from part A. And then that's our answer. So let me show you over here. If I switch this time, and I'm just going to change the symbol to be greater than, you can see that's what the picture looks like this time around for my solution set. So that's where the parabola is higher. The parabola in the shaded region is higher than the vertical line, and that's why Desmos shades there. Okay. With that, you have your first DOL. I want you to you can use graphing or algebra for this one. All right. Example 2, manufacturing. So we've seen a problem just like this earlier in the year, except it wasn't inequality. So let's reload on this. It says an 18-inch by 20-inch sheet of cardboard is cut and folded to make a shipping box with a height of X inches. What height should be used if the volume of the box is to be at least 252 cubic inches? So I want to remind you of this problem. Think of, you have some type of cardboard box that's almost a square, not quite, so it's a little bit rectangular. And it says it's cut and folded to make a shipping box. So the way we cut this, if you remember in class, is I said we need to cut out the corners on the side. So I want to cut out the corners on this box here. After we cut out the corners, we fold up the sides. So I cut out that corner, I cut out this corner, this corner, and finally I cut this corner. You fold along the sides to get our shape. So I fold here, 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 and finally there. Okay, so walk me through. This originally was 20 inches long. And this was 18 inches wide. After I cut the corners, does it tell us how much we cut? So what do you represent by an unknown amount? X. We cut X this way and X this way. So this inside length, is it still 20? No, what does the length become? 20 minus X. So we lost 1X. I do agree we lost 1X over here, but what about on this side? 20 minus 2X. We lost 2 X's. What about the width? Is the width still 18?
No. 18 minus.
We lost a width this way, and we lost a width this way. So it'd be 18 minus 2X. Okay, what about the height? This would represent the height. What does the height measure as? X. So this actually equals our height. What's the formula for volume? Length times width times height. So we could plug in and solve this problem. Now, it says the volume should be at least 252. So question, could the volume be bigger than 252? Okay, so the volume is going to be greater than or equal to 252. So I'm going to put 252 in for my volume. And the volume itself, the 252, notice it's on the small side of the symbol, needs to be less than or equal to. So 252 is on the small side of the symbol. So the point of the less than or equal to. The length we said is 20 minus 2X. The width is 18 minus 2x. And finally, the height is 1x. If we graph this, we should be able to come up with a solution. So here we go. 252 is less than or equal to 20 minus 2x. The extra x is the height. That's the height. So the length is 20 minus 2x. The width is 18 minus 2x. And the height is just 1x. So there's my equation. I'm graphing it. And it gives me two possible solutions. And this one goes on to the right forever. Let me ask this question. Let me first write down the interval. Where does it appear that the answers are? It's not telling us. So if it doesn't tell you, here's the way to get around it. Type in y equals the left side. This is how the insolve works. Y equals the left side. And type in y equals the right side. These graphs will cross at 252. I know that's the y value it'll cross at. So I'll zoom out until I get to 252 up here. Let me just do it this way. I want to look from -10 to +20 over here. And I want to go higher so I can see this. It crosses at 252, so I'll just do like 280. Okay. So here's my problem. It looks like to me the solution set is between 8.4 and 6.29. So the height is x, and that's what I'm solving for here is the x. The x should be anywhere in the range from, did it tell me how much to round? No, it did not. I'm just going to say, let's round, we'll just leave it as thousandths. The answer solution this time is going to be x equals anything between 0.844 to 6.298. 6.298. That is the width you can cut. Now I could do this union and include this part over here, but someone correct why we don't actually have to include that part of the answer. It's a good thought. We did this problem before. I want you to think about cutting, say, 12 inches. What would happen if we cut 12 inches? If you cut 12 inches this way and 12 inches this way, what happens? The whole side falls off. It doesn't work. It's not realistic. This part is not relevant because this graph left the first quadrant. The purple equation lost the first quadrant. So we're going to eliminate this part and say this part is not relevant. And so the actual answer here would be this portion right there. That's the relevant part of our answer. So let me add this into the notes so you can see that that part is not relevant. That went huge. I don't want it that big. There you go. And so only that part would be the answer. With that, I'm going to let you try DOL number 2. So there was a real world problem how you can apply this. Let's just give you a mathematical problem. You go ahead and try to do number 2 here. Now let's look at one more thing with this. And the rest will kind of be self-explanatory. Some unusual solution sets. So first, on this one, if you want to solve this by hand, so I'll do a little algebra here. Here's my A, here's my B, here's my C. If I want to use X method, what are factors of 3 that add up to be 2? What are the factors of 3? Just 1 and 3. That's all we have. And so how do I make 1 and 3 become a total of 2? I need to subtract. Which one do I need to subtract? Is it 1 minus 3 or 3 minus 1? 3 minus 1. I would split my A term right here. And so we would have X minus 1 times X plus 3 has got to be less than 0. So again, if we wanted to, I'm not going to put an equal sign. I'll just do this little squiggly. What is X the value we're going to test? The critical value? Is it -1? No, what value would you test? positive 1. And then what about here? Negative 3. So I would draw my number line. If you're doing the algebra, you would draw a number line. The critical values are going to be at the one on the left is negative 3. The one on the right is going to be positive 1. And so let's pick some numbers here. What's a number less than negative 3? All right, negative 5 minus 1 and negative 5 plus 3. What is negative 1 minus 1? Negative 6, just negative. Negative 5 plus 3 is negative. Negative times a negative is positive. Okay, and the inside, you would have, let's just say, what's between negative 3 and 1? About 0. And then 0 plus 3. Okay, what's 0 minus 1? Negative or a positive? A negative. And 0 plus 3? Positive. A negative times a positive? Negative. And finally, what's number greater than 1? 2. 2 minus 1 and 2 plus 3. What's 2 minus 1? Positive. And 2 plus 3? Positive. Positive times a positive is positive. Okay, so let me copy this because I'm going to use it a few times here. We want to know when we're less than 0. Is there any area where we're less than 0? Between. All right. So in between here. We messed up somewhere. Negative 1 times 3 does not give us. Okay, so we messed up there. That doesn't work, does it? It's not rational. So let me go over here and show you that is not rational. Let's try this here. X squared plus 2x plus 3 is less than 0. Is that ever true? Look at the picture. Do you see any shading at all? That is no solution here. This isn't even rational. You could find the roots, but it's not rational. So this one here is no solution. No solution. So let me erase this because that is all bad math. So all this needs to be removed. And I will demonstrate graphically this graph right here, y equals this, is never below the line y equals 0. You can see that graphically this never occurs, or they never get above or never below. So this time we have no shading because there is no solution. All right, sorry about that. We're going too fast. So there's no solution this time. All right, let's try example B. This time we want to know where x squared plus 2x plus 3 is greater than or equal to 0. And so this time I'm changing this to a greater than or equal to 0. And what can you tell me? What's different about the graph this time? It's always shaded. What do you think that means? Everything. This is all real solutions. This parabola is always above that horizontal line at 0. So this is all reals, or you could say the solution set is from negative infinity to infinity like that, or you can say all reals. The solution set is all reals. You do it that way. All reals. Okay, so that one, because it's always, the parabola is always above the flat line. Okay, let me go to this time. Do you want me to do graphing or algebra? All right, let's just do graphing again. So here we go, x squared plus 12x plus 36 is greater than 0. And so this time I want you to look at the answer or the graph. Notice my background is shaded all the way through, but the one thing that's weird is there's a dotted line in there. So that dotted line, does that mean it's part of the solution or not a part of the solution? It's not. So this is what all reals except for one value looks like. This would be all reals except for, it looks like -6. Should have clicked that here. All real values except for -6. That's the only spot. Let me actually replace my picture here. Yeah, I would be writing this down, the solutions I just put in the, so the first one was no solution. The second one was all reals. This part C is, I would say, this is the solution that would be all reals except for -6. So you could say from -infinity to -6 union -6 to infinity. That means all reals except for -6, or you could actually write that out. So instead of x equals all reals, you would say first x cannot equal -6. But other than that, x is all reals. So you can write your solution either way here. I'll circle that up because that's how Alex does it on your homework. You would write it like that. This is showing all reals except for -6. That's the one value that's not included. And then finally, part D, there's only one little switch here. On part D, same equation, but now it's going to be less than or equal to 0. And what do you notice about this problem? So now it's almost all white except there's one solid line at -6. So what do you think? The only answer is -6. So if you're using inequalities, you would say, not inequalities, I'm sorry, interval notation, you just say -6 in brackets because it's only one value, or you could just say x equals -6, an interval notation. So there's 4 weird solutions and how they could look. So going through them one more time, you could have no solution where you have nothing shaded, nothing appearing. You could have the whole graph being shaded, that's all reals. You could have everything but one dotted line being shaded, and that would be all reals except for that one value, -6 in this case. Or you could just have one solid line, nothing else shaded, which is just one answer. All right, your turn. You graph this one and see what you come up with. All right, when we get to example 4, if you were to do this by hand, the one thing that gets a little bit different, we could do the normal algebra. I just want you to remember there's going to be a critical point that what are you not allowed to divide by? 0. And so I will do this algebraically just so you can see the algebra, and then we'll get our answer graphically. But this will have an extra critical point that you're not allowed to divide by 0. So if you solve the x plus 2 cannot equal 0, this will create a new critical point. So on this one, we would say x cannot equal -2. That's going to have that critical point. What I mean by that is if you were in a test with the number line, you would throw in a -2 on this number line. Now, I don't know what else is there. So I'll use some algebra for a second. I'm going to add a 3 across. And so we'd have 3x plus 4 over x plus 2 has to be greater than or equal to +3. How do you get rid of division? Multiply. So I'll multiply both sides by x plus 2. And so now I have 3x plus 4 has got to be greater than or equal to, let's distribute this. What's 3 times x? 3x plus 6. And then we would, you want to subtract 4? What if anything else I could do here? I would divide by 3. Do I really want to do that? What about just subtract 3x? And so when I do that, what happens here? 0 is greater than or equal to 2. Is that true or not true? Algebraically, did we do any mistakes there? No, it looks like this is going to be no solution. That's impossible. 0 is not greater than or equal to -2. So let's graph this and see what happens. I was expecting to come up with a solution, but that didn't happen there. Let's see, 3x plus 4 over x plus 2 has got to be, minus the 3. has got to be greater than or equal to 0. And so this is actually saying the answer would be from negative infinity up to -2. Now notice they don't do a line at all because at -2 that you're dividing by 0. So let me take these off. And -2 you're dividing by 0. So that shouldn't be part of the equation. Now what I am going to do here is graph this y equals and then y equals the 0. And so you can see that this is a section of graph that's above. I'm not sure what I did over here. We would add the 3, you'd multiply 3x. So ultimately, I don't understand what I did wrong there mathematically, but according to the graph here, this is where you would be above, and so that's what they shaded. So they actually say from the critical point of -2, which we knew that was going to be the critical point. That I did know. And you cannot divide by 0s, which means you're not allowed to equal that spot. You'd have an open circle. What they're saying is if you plugged in a negative number or a number smaller than 2, what's a number smaller than 2? Sorry, smaller than -2. -1's not smaller than -2. -4. Okay. So if you plugged in like a -4, so 3 times -4 plus 4 divided by -4 plus 2, that is going to be -12 plus 4 is still negative. A negative right here. A negative divided by, that's a negative. What's a negative divided by a negative? Positive. So notice that is greater than 0, like we're supposed to be. And so that's why it's shaded on this side. You would subtract 3, but anyways, and then the other side, if we did it, we would get a negative number, and that's why it's not shaded that way. So that's ultimately how it works with the inequality. I would still just graph. Let's just be real. I would graph. So now you go ahead and graph this next one. Call this DOL number 4. Go ahead and graph this. Let's finish off with some word problems. How can this play out in word problems? So it says here, example 5 here, a carpenter is making tables. The tables have a rectangular top. And so to help us visually figure this out, I'm going to draw a rectangle. It has a rectangular top with a perimeter of 20 feet. So the first thing it says is the perimeter is 20 feet. So remind me, what's the formula for perimeter? For a rectangular, how do you find perimeter? Add up all the sides. So you have this width, you have this length, you have this width, and you have this length. So how many lengths do you have? 2. And you have how many widths? 2. Okay, so 2 lengths plus 2 widths ought to equal 20, which in our problem, the perimeter is 20. So I'm going to change that to a 20 right there. There's that formula. And it says we have an area of at least 24 square feet. So area is at least 24 square feet. Does that mean area could be bigger than 24 or less than 24? Bigger. So it could be equal to 24 or it could be bigger than 24 feet squared. What is the formula for area? Length times width. So area would be length times width, but we know our number needs to be 24, with 24 getting the smaller end of the symbol. So we'd simplify a 24 is less than or equal to the length times the width. And if you wanted to solve this, what you would do is you would just substitute from algebra 2. When you have more than one equation, the way to solve is either by using substitution technique or elimination. You use both equations together, you solve for a variable, substitute, or you try to eliminate. I'm going to do substitution. So I'm going to take my perimeter, because that's the one I can set something equal to. And lyric, do you want to solve to get length by itself or width by itself? Does not matter. You tell me which one you want. She wants length by herself. Okay, so if we wanted length by itself, how would I get rid of the plus 2w? We subtract 2w. So I'm doing a system of equation right now is what I'm working on. And so 20 minus 2w is going to equal 2 lengths. Now to get length by itself, I need to get rid of this 2. What's that 2 doing to the L if it's right next to it? Multiplying. What's the opposite of multiplication? Divide. And when you divide everything. You distribute that division through. So I can see that 20 divided by 2 is 10. So 10 minus the width equals the length. So if you had a width, you just take it away from 10 to get the length. That's our formula there for the length. So nice. What you do in a system of equations, once you have one answer, you substitute into the other equation to get your final answer. So I'm going to substitute this into the other equation for L. So I have 24 is less than or equal to, instead of L times W, what I'm going to do is you replace the L with 10 minus W. And I'm just going to use calculator now to solve this one. So we have the equation 24 is less than or equal to, and I'm going to use the letter X, 10 minus X, I'm sorry, times X. And the calculator shows us the answer. If you graph these individually, Y equals 24 and Y equals the other, you'll see that the spot where the parabola here is greater than 24 is in between the values of 4 and 6. So that would be my answer this time around. The interval from 4 to 6. So the length and the width are going to be values between 4 and 6. That would be my solution set. Do that here. Send it back. And so to complete your notes here, you would just say the answer would be between 4 and 6. And I did brackets. Why did I use brackets? Because of the solid lines. So our answer would be, our length and width are between 4 and 6. Obviously, the perimeter would have to add up to 20. And so once you have one length, you would take it away from 10 to get the other. And here's another way you might see real worlds for rationals. So rational again means that there's a division of a variable somewhere in there. And so on this one, I had to divide, well, actually, I didn't technically do it, but if you wanted to solve, you would. That one, actually, I don't know why they call it rational. That's not rational, that's polynomial. This one is rational though. Eric can paint a house in 6.5 hours. Peter can paint the same house in 6 hours. If they were to hire a third painter, how fast must they paint to paint the house together in less than 2 hours? This comes from the idea that speed equals some distance divided by time. Are y'all familiar with this? If you're driving 70 miles per hour, that means you can drive 70 miles in 1 hour. So speed is equal to distance divided by time. Well, in this particular case, there's not a distance. We're not traveling a distance. We are painting houses, but that represents the distance. So on this one, Eric does something. What does Eric do? He paints a house. That means Eric paints one house in 6.5 hours. Now, Peter does something different. What does Peter do? One house in 6 hours. They hire a third painter. They don't name him. They just say third painter. This third painter, we don't know how fast he's got to paint the house, but we do know that together they all work together. They want to paint the house in less than 2 hours together. So if you're doing something together, what would you do with these values? We need to add these up. They don't say equals one house in 2 hours, 1 house in 2 hours. We got to beat that. We got to be better than it, which is weird with time because you want a smaller amount of time. So I think the symbol is going to go this way. I know it seems backwards, but we want the time to be smaller than to win here. To be faster, you want your time, and that's what's unknown, to be less than. So I think the inequality is going to go that way. We'll see in the graph in a second, but we want the faster time. So that's my equation right there. I'll graph it. Let's see what we come up with. So I have 1 divided by 6.5 plus 1 divided by 6 plus 1, plus 1 divided by x. Hold on, Jordan. Is less than or equal to 1/2. I believe that's what we want. Oh, no, I'm wrong. This inequality, this is saying the answer could be like times like 10 hours, 15 hours, 20 hours. No, we want a fast time. So I'm backwards on this. We want our time inequality to go this way. To be less than 2 hours. I need my inequality that direction. So I want to switch it here. And And the reason I know that is because I want a faster time, and a faster time means a smaller time. This would be my answer. And I should ask this, if the time's got to be less than 2 hours, it shouldn't even have the equal to sign. I'm all off on that. It should just be just the greater. I want to be faster than 2 hours. So let me take away the equal to sign. And so the person needs to paint the house anytime less than whatever this is. If I solved it, what does this look like? I'm going to zoom in. We'll round to the nearest hundredth. If I have 5.571 and 5.572, does that round to 5.57 or 5.58? 5.57. So this one, the answer we're going to say is between 0 and 5.57. That's the answer I'm going to put here. That we need to hire a painter who paint the house within 0 and 5.57. So this one here, they need to paint the house in less than 5.57 hours as my answer. Which brings us to DOL number 5. This is just like the problem I just did. You can work on this one. Let's finish this up with the ACP problem here. It says Matthew and some friends are going to a concert. They hire a car service for $75 to drive them to a restaurant for dinner and then to a concert. They divide the $60 cost of the dinner equally. However, since Matthew's dad provided concert tickets for the group, the friends agreed that Matthew doesn't have to help pay for the car service. The friends divide this cost equally among themselves. If each friend spends a total of $25, how many friends went to the concert with Matthew? Wow, there's a whole lot of problem here. This is based off the idea that you learned, I think in like 6th grade about averages, that if you have a total cost and you divide it by the number of people, you can discover what the average cost was. That's how you learned averages. The first question I have for you in this problem is about the very end. What is it we're actually looking for? Like, what's my unknown here? Friends. How many friends? Friends is our unknown. So here's what I'm going to write first. X equals friends. So I saw a few different costs in there. I saw 75, 60, and 25. Let's simplify the problem. Which one's the average cost? $25 is the average cost. Because they spend, if each friend spends a total of, that's the average cost, $25. The total represents the other two are going to be added together. Those are costs. So I know I'm going to have 75 divided by something and 60 divided by something is going to equal the average cost of 25. I now know that about my problem. So now let's go see who pays, how many people pay for 75 and how many people pay for 60. It says they hire a car service for $75 to drive them to a restaurant and then, or for dinner and then to a concert. Next sentence, they divide the $60 cost of the dinner equally. However, since Matthew's dad provided concert tickets for the group, the friends agreed Matthew does not have to pay for the car service. All right. Matthew doesn't have to pay for the car service. So who pays for the car service of 75? Who pays for the car service? Everybody except Matthew. Defined as who in this problem? Friends. Friends pay for the $75 cost. Who pays for the restaurant or the dinner? Everybody. Friends plus 1, which represents Matthew. We can graph this now and solve this one. So let's graph this and see what we come up with. So I'm going to have a $75 cost of dinner paid by the friends plus, excuse me, that's car service. A $60 dinner divided by friends plus Matthew. Matthew's one person, so that's why we got that, equals the 25 average. And so if I copy this side, just to make it easier for you to see, I'm gonna do y equals the left side and also y equals the right side here. And if I look at 25, I should have my solution. The solution would be 5 friends. Obviously, you'd have this negative, but that's not practical. You can't have negative amount of friends. And so we would say the correct answer is just 5. Now, since it's just one solid line and not more than that, no shaded region, the answer would just be 5. It's not a interval or solution set. It would just be the value 5. There is more on here, but that's I'm going to stop there. You can try these on your own. Just a review of different questions we've worked.